In this project, we will implement a simple hospital system. In this system, we have a lot of different specializations. You can say like we have 20 of them, like a specialization for children, for surgery, and so on. Each specialization has a queue, and this queue afford only maximum of 10 patients. So let's say that the children queue has 10 positions. The surgery has 10 positions. If at any point of time the position per surgery is complete, we don't accept new patients. So with the first 10 children, we cannot accept more children. But if we handled one of the children and it left from the queue and then someone else came to the queue, then we put him back in the queue. The program starts with this menu option. Take a minute to read it. We first allowing to add a new patient or print all the current patients. One of the doctors might need the next patient, or maybe some of the patients might decide to leave without seeing a doctor or ending the program. Let's go in details. The adding patient might be the most one that's critical of them. To add a patient, you need to provide three things. What is a specialization that you need? What is the name of the patient? And a status. The specialization is a one-based integer from 1 to 20. If you made your program more generic, then your program starts with n specialization from 1 to n. And then the name is the name, and the status is one of three things, zero-based. 0 for normal, 1 for urgent, 2 for super urgent. Here are the rules. If the patient is normal, we just add him to the end of the current queue of this specialization. If the person is an urgent patient, like someone who has a broken arm, then we add him after the current urgent agents, but before the normal patients. So he has more priority than the normal patients, but in terms of the urgent agents, he is in the end of them. If the person is super urgent patient, someone who might die, we need to put him after the current super patients, but he is still before the urgent patients and the normal patients. I hope you can get a logical sense behind the order of them. So read the requested specialization, the name and the status, and double check if we have 10 patients at the moment. Do not accept a new one. The get next patient, you just provide the specialization and we return the top patient of the queue at the moment. If no patients, just inform the doctor that no one at the moment in this specialization. Sometimes the patient might decide to leave, then we just get the name and specialization and remove him from the queue. If no such a person, inform us about that. The dummy testing. I would like to teach you something that's important. When we build systems like a hospital or library or whatever, you typically don't have a data. So sometimes the students keep adding the data over and over by themselves to the program, but this is very boring and this is very impractical. What we do in practice is what we call dummy data generation. You started to write some extra code that fill the data in an automatic day. So you think about what are the reasonable data. So this way, for example, you generate like maybe 10,000 users in your system, and they have, let's say you are building a Facebook like social media. Then you generate like 1,000 user and upload images and videos for them and generate likes and comments for them. Something that do initial data for the system, then you started to test by building over and over in this system. So if you thought about some scenarios here, you might think, okay, I might need to generate one specialization that will have 10 persons, maybe of all of different statuses, and maybe another specialization with a specific status, like one of them only, maybe another one or two with only two of the status, maybe one of them with only one status, and so on. Overall, you need to think about the different scenarios that help you to verify the correctness of your program. Testing is a very critical skill for every software engineer. So you have to develop your testing like testing intuition about what need to be verified, about what kind of scenarios you need to consider. This is my program. I tried. This is my program running, and I give it initially the option of 2, which is printing all of the current specialization, current patients. As you see, all of the names at the moment are very dummy. I generated this current of dummy data. For example, I generated one specialization number 3 with all of the with 10 patients. 3 are super urgent, 4 normal, and 3 super urgent. I actually generated them with a single for loop. Observe here, like I added them as 0. I added them 0 normal, 1 urgent, and 2 super urgent. So 0 normal came here, but 1 urgent came here, but 2 super urgent came here. Then I generated 3 as normal, 4. So the point of that is I generated them 0, 1, 2, 3, 4, 5, 7, 8, 9 with normal, urgent, super urgent, normal, urgent, super urgent. If you got confused about that, that's okay. I also here created another specialization, number 6, with 4 patients, all of them urgent, normal, another one, all of them urgent, a third one with all of them super urgent, and one of them was only urgent or super urgent. So this is my initial dummy data that would help me during the project. Now I I started to simulate the running of my program. If you give choice number 1 here, I give the specialization number 3, but remember number 3 here has 10 patients. So I got a message that, oh, you cannot add more patients at the moment. After that, I told them, okay, 1, but I'm adding 16, and I'm adding him in the urgent category. Now, if you try to print, you will notice that specialization 16 now has 1 patient, which is Mustafa with the status urgent. Okay, I try to give a choice number 3, which is getting a patient, and I entered 16, so it just asked Mustafa to go with the doctor. And after that, I asked it to another one to get next patient number 3, specialization 6, so it provided me with another dummy 0, and the same again from 15. It gave me that there are no patients at the moment in the specialization 15. So as you see, I'm trying to show you the different cases here with get a next patient. In a choice number 4, which is removing a leaving patient, someone would like to leave. We asked the specialization and the name, but there is no patient with this name. Then he gave us the right name, so we just got this one from the queue. Now if you try to get back to specialization 6, you will notice there are only 2 patients from here, because another dummy 3 left from here, and another dummy 0 was left from here. So only 1 and 2 are remaining in this specialization 6. Let's go more. Let's add. I added here 2 urgent guys in specialization 6. If you try to print, you will notice that urgent 1 and urgent 2 are now in the top of a specialization 6. And also observe that urgent 1 comes here before 2. Because when urgent 2 comes, he will find urgent 1 and another dummy. He will be after an urgent, but before a normal. Let's add all of these guys. I added now a couple of super guys and added another normal guy and an urgent guy. So considering now the update of a specialization 6, super 1 and 2 comes here, then urgent 1, 2, and 3 comes here, then the normal ones come here. So observe always there is an order, there is respect for the order. The super urgent comes always after the super urgents. The normal come after the normal comes after the normals. The urgents come after the urgents, and so on. That's all about this project. I hope you aren't confused about it. Try to review the screens, understand them very well. Make sure your program is simulating my program, generating something in a very similar way, input and output. That's all.